Hello everyone, welcome to Thermal Control Magazine's live interaction session on the future of India's MEP. Mechanical, electrical and public health engineering is the most discussed branch of sustainable construction. World around, MEP services are not only convert a building into a livable space with healthy and ready to move ambience, but it also enhances the energy efficiency of construction structures. However, the present pandemic has impacted the building and construction sector, and its impact can be seen into MEP also. MEP service providers, being the most critical aspect of the construction field, have been facing the crunch of it. Although the Government of India has allocated required permissions for commencement of projects, but the question is, how will they bounce back to the previous momentum? The construction sector is expected to intensify in future. Its amplification will create a sea of engineering opportunities and the MEP requirement. But this does not just come along. We need to focus towards innovative technical aspects. Let's not forget the challenges being faced by the MEP specialists. This is where the engineers and experts bring in technological innovation that can provide value to engineering quality, address the cost complications, and yet fitting them in the right frame at right time. Today, on this note, you are going to witness an engaging interactive session on the future of India's MEP. Our today's panel from MEP and HVAC experts will talk about the opportunities, challenges, technologies, and innovative design for enhanced MEP services in sustainable construction. Ladies and gentlemen, it's an honor and privilege for me to introduce you today's distinguished speakers. Mr. Ravi Sharan, Key Accounts Manager, APAC Swiss Rotors. Mr. Ujjwal Singh, Director, Levanter Air Systems. Mr. Suhas D. Randive, MEP Consultant, Design Engineers, and Mr. Anirudh Bapad, Head MEP, L&T Realty.
So, delegates, let's get ready for an engaging session uh, on the future of India's MEP. The first topic is the need of the hour, standardization and automation in HVAC technologies, which will be presented by Mr. Ravi Saran. He is presently associated with Swiss Rotors as a Key Accounts Manager, APAC. He holds an extensive experience of 20 years in both domestic and international markets for air conditioning and HVAC segments. He's a mechanical engineer and an MBA. His expertise in the HVAC segment includes services like key account management, international business developments, institutional sales and marketing, project handling, management, and information systems. To take this session forward, I would like to invite Mr. Ravi Saran. Uh, yes, Mr. Ravi, please welcome.
The burning question today is when we are talking about the future of the India's MEP. The one question that comes to our mind is like, what's stopping us to, upgrading our technology from launching ourselves to the next level of technology where we are looking at higher energy efficiency. When we're talking about indoor air quality, what's stopping us from getting into a higher level of technology and products? The main question that is hanging in the air today is that when we look into higher technology, we do have to have it available. It has to be dependable and it has to be affordable. So I'm just going to share my screen and I'm going to talk about the technological aspects, the region where we are afraid to walk in, but I would like to open up the discussion to everyone and understand why we need the automation and standardization to make it workable for each one of us. Okay, cool. So need of the hour is standardization and automation in HVAC technology. This is the topic I wanted to, it's a rhetoric question, basically, what we need to do to bring in a model which starts with developing a higher technology. For example, innovation has to be included because we want to upgrade. That's the need of the hour. But when we bring in higher technology, what we need to keep in mind is that it has to become accessible, it has to become available, and it has to be and accuracy has to be developed so that the tangible benefits are percolating down to the end user. It has to be also affordable. Now, to make that possible in this value chain, we have to include and we have to keep in mind the end customer who has to benefit from it, have it available, have the tangible benefits, and make it affordable. What makes it possible is in the middle of the triangle we have highlighted: standardization and automation. This is what is helping us percolate the technology down to the level where people can actually absorb and enhance their workable, their working environment, their technology, their own business models. So once you may decide to make your end customer part of the value chain, then only we can talk about why we need to invest more in standardization and automation. Investing in innovation and bringing in technology, doing research and development is one aspect, but making it workable, making it something which is tangible and which is absorbable by the people who want to use it is another aspect. So what stops us from launching ourselves to our next level of technology is probably the cost aspects. But when you have this in mind, standardization and automation, it can actually help you do that. Let me treat you to a small video on what I call where we are able to develop and provide a higher technically advanced product line, help of technology, viable in terms of cost, accurate, and also accessible. As you can see, we are using robotics in some of the factories. There's no room for human error over here. Then you need no room for human error. We are actually addressing the wastages. There's no wastages as well. High precision, highly automated, and no room for errors. What you're seeing right now is the plate type heat exchangers and the room that will be able to give you one of the best technologies, the highest of precision. It's a lot of investment in the process side. As you can see over here, I'll stop here. The wheel media, which is probably a 2.4 meter, has no support in the metallic side. As we know, the wheel is about the air which is being subjected to the heat exchanger for recovery of energy. So when we are talking about high precision in the process side, the investment in the process side, does it actually mean that it costs more? No. What we were keeping in mind is that it has to be a viable technology. It has to be something which can be absorbed and inculcated in the systems where the end users are involved. Keeping in mind the strategy is that that should be high in quality, should be a very fast process time, and it should be best of the prices. That's when the model becomes successful. So talking about Swiss rotors, it is actually based out of Switzerland, of course, as the word says, where the research and development has happened. And it has one of the best factories in Poland, in Dubai, as well as in the US, where this is being successfully followed. So I would just start with the energy recovery wheel and the plate type heat exchanger, because this is where we are talking about indoor air quality, which is really a touchy subject today, and also energy recovery. Both these aspects are being addressed by the two verticals that we have formed, the plate type heat exchangers and the rotary heat exchangers. So what happens is energy recovery wheel, as we all know, is basically taking the energy from the exhaust air and using that energy to precondition the incoming fresh air. We all need fresh air in a conditioned environment because that air needs to be flushed with the fresh air. We have to flush out the recirculated air, and we have to bring in fresh air. So the energy recovery wheel sits inside a air handling unit, and it helps to lower down your cost of the refrigeration, where we are having a 4-row deep coil or a 5-row deep coil. To address it, we can downsize your refrigeration load when you start to include an energy recovery wheel. Now, what is the change that we have done? What is that innovation that we have involved here? Here, as you saw in the clip, the energy recovery wheels was having no, it has applied for a patent in how the winding is done so that the maximum surface area is available. What benefit we are getting out of this is that anyone, that means even your kid, can go onto the web page and do the selection software itself. It has been made completely transparent. The second vertical that we're going to talk about is the plate type heat exchanger. Another aspect which is very important today when we're talking about cross-contamination issues. For example, when we are talking about data centers, hospitals, we really don't want any kind of return air to get into the supply air. So very important that the energy recovery which is done is one of the highest. When we want to go for a higher energy recovery, what we can do is develop a heat exchanger which is offering a larger surface area. So that is where the innovation is gone. The winding technology in the energy recovery wheel makes it possible to address higher CFM flow, addressed with a smaller footprint. So when you do a selection here, you can downsize your air handling unit size as well and have the right efficiency aspects with a certified performance from Eurovent as well as HRI. Then I come to the second aspect, which is the plate type heat exchanger. The plate type heat exchanger has now was subjected initially to around 60 to 70% efficiency, but now we are offering 90% efficiency with a cross counter flow, also called the hexagonal type plate type heat exchangers. So wherever there are concerns on the cross contamination in the hospital, data centers, IT centers, labs, we can easily choose this one. The limiting factor was that when you go for a higher airflow, the air handling unit size was becoming very bulky. So this becomes a game changer. Again, we have cross counter flow, which has higher efficiency and a smaller footprint, and yes, less price as well. So the third is another innovation from Swiss Rotors, which is when you're talking about larger airflows as high as say 24,000 cmh or even 40,000 cmh. This can be addressed through something called the hex wall, where we have put the counterflow plate type heat exchangers in parallel so that we are able to address larger airflows and still have the higher efficiency, sensible recovery, and have 100% separation in the airflow. Now, when we're talking air or treating the fresh air, when you're bringing the fresh air inside a building, which is so much important today, and we have all realized that the indoor air quality has to be very good, has to be attaining a certain criteria, then we can address it through the two-wheel phenomena, which is the sorption wheel, the total energy wheel, plus a sensible wheel. The innovation has gone into making a smaller footprint again, and this becomes as a ready-to-fit unit inside an air handling unit. So the energy recovery wheel, what is the game changing? It's all about the controls. Believe me, when you talk about an air handling unit with an energy recovery wheel inside, I'm sorry to say, but that we do lack the expertise when we are talking about controlling and diagnosing what is going inside the air handling unit. So when we choose to put a stepper motor there, the energy recovery wheel being run by a stepper motor, we are actually enabling a lot more into monitoring and controlling that aspect. So even after 4-5 years, the energy recovery wheel is working perfectly or not can be easily monitored when you choose to have a stepper motor there, because it comes along with a control system, which will actually be helping you to detect if there's a rotation which is stopped, if the energy recovery is not delivering off-wheel temperatures in a unity is not as per the expectation. You can easily monitor that and make sure that the life cycle cost of your air handling unit is what you promised to your end users. So all this was additionally being given as an additional cost. Swiss Rotor has made it a standard to give an energy recovery wheel with a stepper motor and a control. And guess what? It is not so expensive. Why it became so viable is, you refer to my video over there, investing in your process to make that technology viable for your use is very important. That's how you can get the best of the technology to your doorstep without any extra cost and making it transparent so that you can actually check the performance by itself. So you walk the talk. You don't just say that, okay, this will happen, but you make it show. You show it what we are going to do it and make it viable, because it has to make sense to your bottom line. So this is what the energy recovery wheel conventionally looks like. If you want to have a control over its off-wheel temperatures and humidity, you will have to have the AC. It is what you being used with an AC motor, with and then you would have to have a VFD with it, with a reduction box gear motor, and then you will be able to monitor it. But what we are giving you is a small compact, what we call a stepper motor. This stepper motor is nothing but enhanced EC motor, which will have a control panel by default over here. This can also be monitored in front of the air handling unit, so you can monitor its working. Now, when we talk about cross contamination, the energy recovery wheel has some innovation, because the return air is getting rotated. It's because of, and you need to have the right purging, and then there would be aspects where you don't want to have any kind of cross contamination at all, and the two airflows are completely separated. That's when the controls, when we talk about the counter cross flow, which is also called the hexagonal. A small video for you. So what I showed you is how what happens inside a hexagonal plate type heat exchanger. So we have nothing against cross flow, except that the exchange of energies inside a cross flow is not as efficient. In the construction, we are in the aluminium. We have ensured that the sealing is perfect. It is a double fold sealing, in which it can also be subjected to as high as 800 pascals of pressure differential between the airflow. In a recovery wheel, it will 500 pascals to get address higher pressure differential also. Each and every plate type heat exchanger is going through a EN 308 testing norm when it goes out of the thing. That means 100% of that exchanger is being tested, not a random test. Great. So this is what we are talking about in terms of counterflow, and I would like to just give you a snapshot on counterflow versus crossflow. What we have been conventionally using is a crossflow, where we have cold spots. So the media, as you can see, the core of the media has cold spots. That means that is where the air exchange would be limited to only the point where they are having a point of contact. So the surface area which exchanges energies are only these. So basically, this is the area of low efficiency. But when you have a hexagonal plate type heat exchanger, the airflows, for example, this is the return air which is being exhausted. The return air being exhausted will have a contact with the will exchange the energy with the temperature with the incoming fresh air, which is being included in before the coil. So you can see the surface area which is in contact. The contact time has been increased with this particular aspect. So this is where we have the highest efficiency, and this is completely missing with the cross flow. So to put it in a nutshell, you need to have 1.5% larger surface area available in a cross flow to meet the efficiency of what the cross counter flow, the hexagonal plate type heat exchanger can offer. So this is why we can reach up to 95% efficiency, whereas this is actually having maximum 70 to 73% of efficiency. So this is all certified data available on our web page. We walk the talk. You can go out there and see what is being delivered. Now, the burning question about plate type heat exchanger is when you want to enhance the air volume, it becomes a very bulky unit, and the air handling unit becomes huge. The hex wall then comes to as an innovative product, where we are able to put the plate type heat exchanger in parallel, and then able to address even the size of the unit and address a larger volume as well. So the salient part is that, yes, we are able to understand that there should be zero or nearly zero EATR, which is the exhaust air transfer ratio, and it should be able to address large air volumes. It should meet the norms of efficiency, and it should have fit and forget aspects. So this is all being addressed through a hex wall. If you want to take a look, we can go onto our web page, see the do your selection software itself, and it's simple physics. Just put the air volume, temperatures, and humidity, and you can download the certified performance. So definitely, when we do a apple-to-apple comparison, higher efficiency and lesser pressure drop. And what we're talking about is also lower cost. Why lower cost is because we have spent a lot of time and invested into the process by bringing in standardization, bringing in automation to deliver to you and land up with a smaller media that is a smaller cost to us. That cost is not being transferred to the end users, and we make it cheaper for them. So you have a cost comparison with some of them. As you can see, this is if you will optimize around 8,000 CMH, this unit would be a HW500, where our efficiencies are much higher compared to a cross flow, and the pressure drops are lower. So any air volume, and we have seen that you can have the benefit. See, we have even done a cost comparison, basically is lower by 2,761 euros for when you're addressing it through a hex volume. Double wheel is another aspect which I've already done. I think I should not touch base too much, but what we have done is it's just a smaller footprint can be given to you. And if you have a larger footprint in the air handling unit, it becomes more expensive. This can be just a ready to fit aspects over here.
Next session, I would like to invite Mr. Anirudh Bapat. He's presently positioned as in L&T Realty as a head MEP. He has successfully set up an entire MEP department in L&T. He is an electrical engineer from GEC, NIT Raipur, and an MBA in operations management. With an extensive experience of 30 years, he has a hands-on expertise across various segments like steel plants, airports, real estate, and also he has been instrumental in spearheading smart, green, and sustainable development in L&T Reality. Today, he will give us an overview about the future of India's MEP. So, delegates, let's welcome Mr. Anirudh Bapat.
So coming to the topic of future of India's MEP and overall outlook, we are entering into the era when the pandemic, we had just encountered a lockdown phase. Pandemic was there. This COVID-19 situation has forced us to look other ways of working other than office, like work from home and all. Similarly, because of this COVID scenario, people are now looking for commercial spaces where these CCTV cameras are required to do much more job than earlier it was designed for. So the scope of MEP services is widening day by day by leaps and bounds. COVID-19 was just an example, but if I had to explain, there are so many features in MEP we are seeing getting added today. Like, for example, you take fiber to the home, FTTH. 5 years back, it was not talked of, but today I had to design buildings which are FTTH inbuilt, FTTH ready. You talk about non-conventional energy resources, I had to build in my MEP design, like solar, at few places wind also. Organic waste composters, they have to be an integral part of your design. Rainwater harvesting system. 10 years before, no one has thought of that it will be part of MEP. Slowly, if you will see, the boundaries of MEP are getting widened by these all components which are adding every day. The point here I would like to highlight here is all this definitely is making the future bright, but also it is increasing the cost of your MEP services. People come from that conventional background who think that MEP will cost 15% of your project cost. But today we are in an era where your MEP for a typical residential building are costing you 20 to 25% of your project cost. And for a high-end commercial building, it is costing you 30 to 35% of your project cost. MEP, when I am talking, I am including vertical transportation, elevators also in this. Now coming to the biggest buzzword in today's construction industry, that is green and sustainable construction. MEP has also taken these components of sustainability and green into its stride, and we are building the structures with energy efficiency components, water efficient CP and sanitary fittings. These all factors are adding to sustainability of the building. Of course, sustainability has got much more other than MEP, like architectural design, construction material. But apart from that, your MEP services are also adding lot many credit points to your green building certification. COVID-19 has asked for the pandemic ready structures, which will take care of your face detection cameras, mass detection cameras, social distancing. Lot of touchless operations have come into force, like people are asking for touchless elevators, touchless water taps. So these are adding, and definitely for today's topic, these are making the MEP future globally, not even in India, very, very bright. Also, over the period of time, I have experienced lot of IT interface is getting added into MEP designs or MEP systems. Like earlier, ELV consists of only fire alarms, smoke detectors, and CCTVs. Now, if you will see, there are access control systems are required. There are the CCTV cameras, as I told you, are required to do much more job, much delicate job compared to earlier one. Then boom bollards are there. So these are systems are adding to MEP services, which are having IT interface and ELB interface. MEP systems are also asset specific. Like for residential, you have to design system with a different thought process in mind. Commercial, then a new asset class has emerged like data centers. So the cost of MEP systems is also varying for all these asset classes. There is another asset class, retail, malls. So if you will see, typically the cost of MEP system varies from 15% to 200% typically in a data center. The point here is all these disruptive and immersive technologies with the advent of BIM and Revit modeling has been adding a lot of interesting options in MEP design and systems. You will also have to look only in design, not only in design, we will also have to look the execution excellence and operability of these services, because many times we see we design a very good system, either it is not executed properly or due to lack of SOPs, they are not operated properly. So it's MEP system designed to handover and operation, all it's a close-knit cycle, all goes hand in hand. Now we have much more better way of coordination with architectural and structural team by the way of Revit modeling. It helps in clash detection of the projects. So in totality, I would like to suggest to the larger audiences that the future of MEP looks very brilliant, and it has opened up as many new areas for us to explore.
To our next topic, I would like to invite Mr. Suhas Randive. He's an MEP consultant with design engineers. He's an electrical engineering graduate and has been actively involved into HVAC and MEP segment for the last 12 years. His expertise include MEP services and consultation, HVAC consultancy projects and project planning. And also, he has been associated with ISHRE as a member. Today, Mr. Suhas will be discussing about engineering HVAC designs for buildings. So delegates, let's welcome Mr. Suhas Randive.
So for designing a building construction, one of the main aspect of the designing is the calculation of heat load. For calculation of heat load, this is an example of Mumbai condition. For calculation of heat load, you require a temperature of summer, monsoon, and winter. This is an outside ambient temperature of which we are designing the system. After designing of the system, we require to recover what is the temperature required for designing the system. It is 75.2, it comes to around 24 degrees centigrade with 55% average. This is an occupancy. I've given a 30%. I've considered an occupancy of 30%, and I considered an equipment load of somewhat of 8 kilowatt, a number of agencies. So these are the main aspects while designing the heat load calculations. After designing of heat load, there are some of the factors like which are the glass area exposed, which are the walls area exposed. So these are some of the U factors which we have to calculate while designing the heat load. So what is a summer factor? What is what is a exposed glass factor with 5 m thick, with 5.m double thick, exposed wall factor, exposed partition wall factors. So all these factors are given for summer and winter conditions. So you can design this, you can insert these values in a heat load calculation, and you can see all this data. According to that, you can design the heat load system. After designing this, then there is a load for exposed roof also, exposed false ceiling also there is a load, then ceiling also another. After all designing this system, there comes an what kind of air conditioning system we are going to either. After this making a heat load, it comes to certain derivative of refrigerant TR. After refrigerant TR, then we have two kinds of system. One is centralized system, one is DSK. Centralized systems consist of air cooled chillers, water cooled chillers, and vapor absorption chillers, which is also known as WAM system. So while designing the system, our centralized system, we have options for air cooled chiller, we have our option of water cooled chiller and vapor. After air cooled chiller, so we have number of options. Air cooled chiller, we have air cooled condenser also, we have a package unit also, we have a chill water pumps, air handling unit, and chill water expansion tank. After designing an air cooled system, then we have options of there are numbers of chillers available. From this, we have this is our reciprocating chillers, which comes from 20 to 120 TR. Now, this is an old technology. Reciprocating chillers are almost replaced by a scroll chiller, but this technology is still available with us. So I would like to say this technology is not that proven. So it is now it is up to they are obtained to the scroll chillers now. So this is a scroll chillers we can use from 11 TN to 90 TR. When we calculate the heat load, if our tonnage comes around 90 to 90 TR, we have options of air cooled chiller. These air cooled chillers have to be installed exposed to an ambient. It does not require any roof shade. It should even exposed to an ambient. It can be installed in terrace also. Similarly, it can be of this is of screw chillers, the scroll chillers, screw chillers. This 45 to 425 TR. Then we have a magnetic bearing centrifugal chillers also 60 TR to 450 TRs. Magnetic bearing is an oil-free compressor, so there is a no oil. Then we have a package unit of air cooled system, which from some this package units are mainly used for small air. Then we have a water cooled system. Water cooled systems of water cooled condenser. We have water cooling tower. We have air handling. We have chill water pumps. We have a chiller package unit and chill water expansion tanks. So we have a water cool. This is also a water cooling or reciprocating chiller. Previously we had a air cooled chiller. Same comes with a water cooled chiller also, which comes from 20 TR to 125 TR. This is same of a scroll chiller, which comes from 12 TR to 95 TR. This we have a screw chillers from 50 TR to 385 TR. This we have a centrifugal chiller of single compressor from 230 TR to 12,000 TR. We have a dual compressor of 500 TR to 1,400 TR of this centrifugal chiller. Centrifugal type, there are two types: single compressor 230 TR to 1,200 TR, dual compressor with 500 TR to 2,004 TR. This is a magnetic bearing centrifugal compressor, which is commonly used nowadays from 60 TR to 450 TR. When we have a same way like air cooled, we also have a package unit of water cooled package unit also, which are widely used. This is the WAM chiller. WAM chillers are also used for this. These are mostly used in hotel industries and all. It is used for the exhausting of steam, which can be used with steam, hot water, boil, fuel, and exhaust also. These are the types of. It is a component of WAM chillers: evaporator, heat exchangers, condenser. So water cooled chiller consists of cooling tower. Cooling tower has a counterflow also and close flow. Cooling towers are available in counterflow also and cross flow. This is a horizontal monoblock centrifugal pump, which is which can be used for for the chill water system. This is a split casing pump. Then we have a back bullet pump, horizontal pump. This is a installation of horizontal back bullet pump. This is a new type of technology, vertical inline pump. Vertical inline pumps are basically a new type of technology. It does not require any stand. It does not require any platform. It can be directly installed. It requires a lesser space than lesser space than horizontal pump. So vertical pumps are widely used. It is a closed loop expansion tank which is used for designing of Expansion tank requires a closed loop expansion. Then there is a direct expansion, the DX system. DX system consists of split AC and variable. Split AC consists of sir, split air conditioning, floor mounted, wall mounted, and ceiling mounted. Sir, split air conditioning. Just of split AC, this is split AC which is we have, which we install in our house. This is a floor mounted indoor unit, because we mostly see this type of unit in hotel industries, conference, or this type of marriage bureau, or this marriage hall. You can see all that system in this. Then this is a common indoor unit which we have seen in everyone's house. So this is a commonly used of wall mounting unit of a split AC. We call this. Then we have ceiling mounted, expose and conceal. Expose consists of expose which can be easily this is an expose cassette unit, which is a cassette of this unit. This is concealed because it goes inside the poly. Only we can see a duct inside of it. Then this is a type of cassette unit. We have a cassette unit of ceiling suspended and ceiling mounted also. This is a ceiling suspended. So what capacity we have available from 1.5 tier to 4 ton we have. Refrigerants we have a R410 also. RT2, R22 nowadays now getting out. Then we have a ductable unit also. Then we have an air cooled condenser. So this is an air cooled condenser which we see our indoor unit which we see in our house. This outdoor unit, this is called an air cooled condenser, sir, which has a rotary compressor. Then we have latest technology VRF system. VRF system is which is popularly used nowadays. This kind of system requires refrigerant. There is a lot of with a single outdoor we can install number of indoor units. There is no restriction in pipeline length. There was a previous restrictions in piping length in DX system, but it is not required in the VRF system. This VRF system with single outdoor, we can carry multiple indoor units. With this multiple indoor units, if one of the refrigerant of this unit gets disconnected, the rest of the unit still works with it. It is a less time consuming than this. So this is a wall mounting unit, which is what are the systems, what are the components in the this is wall mounting units we have. We have a cassette unit with this. We have a cassette with two-way also. That's what cassette was previous, one-way, two-way. This is four-way cassette. Then we have a ductable unit also, which can come from 0.8 tier to 8 tier also. Then we have a cassette, ceiling suspended cassette also, we have, which is four-way also. Then this is how we are outdoor units will have, but single outdoor, which will connect multiple indoor units. This is an air handling unit, which is a typical air handling unit, which are maximum static pressure you can install, which can be installed with chill water system also, DX system also, and VRF system also. This is a fine components which can be used. SSW fan can be used, single inlet, single outlet fan can be used. Backward curve, forward curve, then DIDW, forward curve, backward curve. Both the fans can be used. Double inlet centrifugal person. This is type of fan which can be used. DIDW fan. This is a centrifugal type of fan. They does not require this bearings. They can be directly installed. This type of filters what type of filters are used? Then two-way mixing wall, three-way mixing wall. These are chill water system. We can use two-way mixing wall for two-way system. This is a thermostat expansion wall. We can use for DX system. Then there is an electronic expansion valve which is used in VRF system, which can be used to regulate the flow of refrigerant.
Now I would like to invite our next speaker, Mr. Ujjwal Singh. He is the director, Lavender Air Systems. He is a young enthusiastic entrepreneur with a bachelor's degree in mechanical engineering and MTech in renewable energy. His experience in development of air handling units and evaporative cooling systems for various industries. His skills include engineering calculation while designing an HVAC system and providing controlled cooling solutions in construction buildings. Today, Mr. Ujjwal is going to discuss about maintaining hybrid cooling in buildings during various climatic conditions. So let's welcome Mr. Ujjwal Singh.
One thing that I noted was what Mr. Anuruddh said was very correct, that we do need to look forward for the installation part as well. As what today I felt lack in the most of the MEP companies in India is that we do good on the calculations part, we do good heat load calculations, we do good designing. The client looks very happy when we show him the presentation. So much savings will be done, so much things will be done, you will be like this and that. But most of the clients, when the installation part is going first, most of the MEP installations lack to meet the timeline to deadlines. Like it is like it's a culture in India. Like आपको अगर it's an event on 7 o'clock, we invite guests at 6 o'clock. We know everybody will be late by half an hour or 1 hour. Same thing goes with right now with the MEP installations. Like the project deadline, even the client itself expects that it will be getting delayed by a few months or few weeks. So that has to be something that has to be taken up by us as an MEP solution providers. Secondly, what I felt in India right now is that the client is seeking to have a one shot solution. He doesn't want to design by somebody else, then to search for Hitachi or Voltas, ki sir, what is the rates and what is the everything, and then find an installation team and getting the things installed. And then if the system doesn't work, we play a football match where everyone is blaming the other party, that the design is weak, somebody says the installation is weak. So now the MEP solution providers need to tie ups with the manufacturers, tie up with installation team, and give the client a single solution where he can sit on the table and just watch everything being going on, and has a single person to connect to for any mishappenings or any kind of disturbance. So let I will just quickly come down to what I wanted to speak about. What I felt in India, that India is a very diversified climatic zone. From Jammu Kashmir, Kanyakumari, West Bengal, there are a lot of humidity changes. There are a lot of temperature changes. Even in the day and night temperature, I live in Jaipur. I used to be living in Delhi, so there are a lot of changes in temperatures, and there is no single system, whether it be water cooled, air conditioned, evaporative cooling, air cooled, air conditioned, that will meet the perfect requirement of any location. So today, as the topic says, the future of MEP. I don't know exactly about future of MEP. I can talk about future of HVAC systems. So future of HVAC system is hybrid systems. A system smart enough to judge by itself what kind of cooling solution I need to give to the premises. So, for example, if it's a very dry climate, hot and dry climate, I should be giving evaporative cooling to the premises. It will be sufficient. If it's a very humid climate, I should go for dehumidification. If there's too much temperature difference between the exhaust air and the supply air, I should go for it. I should start my desiccant wheel or enthalpy wheel to compensate for the losses of the escaping of the air. Kind of that. So I came up with a small flow chart that will direct. I provided a solution to one of the client in uh, Manesar, and he's quite happy with it. So I would like to share that small flow chart. This flow chart consists of two types of cooling system. It can be three types. Sorry, Mr. Ravi, there's no desiccant wheel in this one, but next time we'll include that one as well. So there are two kind of colors you can see. There's a light.
Definitely will look for that. Thank
Yeah.
you.
There's light green color in there, and there is blue part in there. The blue part indicates the chiller circuit, like the air conditioning system. You can go for any kind of air conditioning system. If it's a dry climate, I would recommend you have water, and it's a dry climate, go for a water cooled system. If it's a humid climate, water cooled system won't be much effective. I think it is better to save cost on investment and go for an air cooled. Depends on climate to climate. It's not hard and fast for any specific area. But the beauty of this system is this system consists of a dual part technology. It has a system where all the evaporative cooling segments are there. There's a two-stage evaporative cooling. I think most of the MEP designers now have heard of the system called IDEC, indirect direct evaporative cooling. It's basically a better version of evaporative cooling where we can get a lower humidity and 3-4 degrees lesser than evaporative cooling. So it is somewhere lies between an air conditioning system and evaporative system. It's bit costly compared to evaporative cooling. So depends on climate, and depending on the budget the client have, he can choose between which system he's want to go for. So let's talk about a sample situation. Let's say I'm in Rajasthan, I'm in Jaipur, and right now it is the month of April. It is very dry and it's very hot, but fortunately the wet bulb temperature around the area is very less. Let's say in April, I think it's 19-20 degrees Celsius in Jaipur. So if I run a evaporative cooling system or IDC system, I will get an air outlet of 21 degrees, 19 degrees, 18 degrees based on how good I made my system. So that air will be sufficient enough for cooling the premises without using any air condition. But as such, if I say ki this is a very good system, sir, buy my evaporative cooling system, the client will be very happy until July arrives. Then we will be like, sir, it is very humid, it's very humid. So, and if I go and if I say no, sir, it will be very humid for this, you should go for a chiller system. In that case, what will happen is he will be very happy throughout the year until the bill of the electricity arrives. And it is like, this is not viable for me. It's not viable for the profitability of the company. I need to go for a energy saving solution. Then he'll be again running for the energy saving solutions. Uh, so we need to come up with a system that can deliver both energy saving as well as without compromising on the temperature and humidity inside the premises. So that's this system. What it does is, first there's a sensor which senses the outdoor humidity, outdoor temperature. After sensing that, he calculates that if I going to run an evaporative cooling system, what temperature and what humidity, supply air humidity and supply temperature I'll be able to deliver. Then he goes to the client side. He checks the input side the client has input. That client has inputted that he wants to maintain that premises at 25 degrees Celsius, or he has inputted 23 or 27. So if the system judges that the amount of air I'm be putting through, the temperature I'm putting through will be sufficient enough, the system will start running an evaporative cooling system and will cool the premises. If the system judges that no, this is not sufficient enough, suppose it's a month of July, the system will judge that it's too much humidity outside, evaporative system won't be able to work to maintain the humidity inside. The system will automatically switch back to the cooling system, chiller system. So that way, the customer will be happy in the month of April, May, June. By the evaporative cooling system, will be getting the savings. He'll be very happy with that. And for the month of July, August, and part of September, he'll be happy that I'm getting my comfort temperature, comfort humidity by using the chiller system. So we get the best of the both of worlds in summarize. So that is what I wanted to say, that we need to come up solutions like these, and not just in the sector of cooling systems. Somebody was talking right now about the filtration system, the air quality inside. So I also think that there's no need to put HEPA filters every time. You need to judge what kind of air quality is outside and what air quality we require inside, and the system should select that right now I need to use a HEPA filter and right now I need to use a wire mesh filter or things like that, so that the life of a HEPA filter can be extended a longer time. I used this system on a data center in Jaipur for ICICI. And one more thing that I wanted to emphasize on, that there was a question that came up during this, that what are we lacking in the connection to the client to the MEP solution providers, where we are lacking. Where we are lacking is that we are telling the client this is the system and this is the cost. There's a third very important key aspect that we need to tell, sir, this is the cost, this is your ROI. If we are delivering a very high expensive system, like say enthalpy wheels are almost the most expensive things that I've seen in the HVAC industry, they are, but they delivers on terms of cost saving in running costs. That is why they are very efficient, right? It's very popular these days to use enthalpy wheels, desiccant wheels. The reason is they are savings on cost. So I met with the ICICI, I discussed everything, and I told them I am giving you a normal cooling system, two-stage cooling system. This is the system that I proposed to them. It's a very costly system for a small data center that they were having. It's costed them 56 lakh rupees. But when I told them that I'll be giving you a savings of 33 lakh 40,000 in single year, they were very happy to go ahead with it. And to be very honest, as Mr. Prakash said before, that I am an entrepreneur. I just started 4 or 5 years back. I'm not that kind of experience on, neither my company has that kind of name value like Swiss Rotors, that I can use that. So I had to rely totally on my calculations, I had to develop the credibility on spot. And the calculations that I showed, the things I told them, gave them the confidence. They tried it. This project won the award for CII for most innovative projects in India in power saving sectors, in building sectors. So my advice to every my uh, family member, I can say the MEP family, is that you need to convince the client on the ROI rather than just the cost. That's a this product is cheaper or this product is more efficient. Don't just say singularities on this. Combine them and tell them this will give you an ROI of this value. And one thing that also that I would like I experienced in my career is that the MEP solution providers these days are saving themselves by oversizing the components. For example, if their heat load calculation says there are 20 TR or 200 TR requirement, they add 60% or 70% as a factor of safety and gives the client, because that money is not going from their pocket, that will be going from the client pocket. What is going from their pocket will be the satisfaction that yes, cooling is maintained, the design was perfect. Obviously, you are putting 60% additional, that design will be perfect, but it's not a good practice that is going on. So when what I said in the start, that we need to unify all the three things: the manufacturer, the installation part, and the designing part. If we do that and if the company is doing the installation by itself, it is taking the project as a whole, the company won't be able to do such things, because then it will be quoting on the whole project rather than just for the designing of it.
So Mr. Ujjwal Singh rightly pointed out about dealing with realistic deadlines for MEP projects. And this is
Right.
again comes with the COVID situation, dealing with skilled availability of skilled labor, skilled manpower. And how do you see it? How it is going to create an impact, or is it we are heading to a different kind of culture of committing a deadline and keep on extending it? It's even escalating the cost.
What Mr. Ujjwal Singh had pointed out initially, that problem would not be a permanent scenario looking at the situation like developing countries like India. But yes, I do agree what Mr. Ujjwal has said, that in coming next 6 to 8 months, this situation will prevail. But once we move out, because if you see recently the migrant labor's story, in Mumbai, what we have witnessed, the migrant laborers have again started coming back after Diwali, and in December, almost the labor scenario is 80% occupancy is there on construction sites. So you see, they are in need of job at villages and at their native places. They won't get such type of job which will give them continuous, salaries and monies. So unemployment rate in our rural part of the country is very high. So the migrant labor will come back as soon as you will give them proper employment. So I think what Ujjwal has raised this point is likely to prevail, but not more than 6 to 8 months. But the larger problem is realistic deadline. See, in MEP, what we have observed, you suppose if you have a project with timeline of 3 years, your core and shell guy will take a luxurious time of 2 years for his all slab building. And then last 1 year is left, you have to complete the MEP also, you have to complete the finishing also and hand over to the client. There is what I was trying to highlight, that there is very little attention paid for MEP execution. You may have done a good design, but if you are not spent equal time on execution, your system will not function to the fullest satisfaction. That is what my gut feel is.
Yeah. Also,
Right.
Mr. Anirudh, how do you look at the availability of skilled HVAC professionals in India for the growth of MEP?
We have abundant, absolutely. In India, I don't see anything, as Mr. Ujjwal has rightly said, then Suhas has elaborated. We have full battery or inventory of HVAC skilled people and HVAC equipment as well. Mr. Ravi has shared in heat recovery wheel 5 years back. Heat recovery wheel nobody used to put, but now in lot of innovations are coming up in heat recovery wheels as well. Swiss rotors is one of them. I could appreciate when he was presenting that. So rest assured, we are equally comparable to the developed nations.
Mr. Ravi, what are the critical design parameters for high-rise and industrial installations? And how do you see BAM for other technologies helping MEP?
Definitely, BIM is the way forward and definitely helps. It cuts down so many aspects. See, right now we're talking about deliverables. Let's have tangible numbers, which, I was saying that when we have technology enhancements, the design conditions, perfect. What we need to understand is when we're looking at designing a building in certain area, as Ujjwal also said that you cannot have a thumb rule for every building, every location. It has to be designed as per those aspects. Look at the condition, what needs to be addressed. Is there a room for energy simulation where we can provide a better solution with a lesser initial capex as well? And the region where we really don't want to tread into is the life cycle costs. So when we initially incorporate a system which is addressing the life cycle cost, that's the way forward. And the designing part is where we have the consultants which look at the latest technology and how we can enhance it, how we can better the efficiencies, how we can include that without bringing up the initial capex is very critical. So you have to keep upgrading yourself. And what I'm trying to emphasize over there, upgrading yourself does not mean that you are incorporating more capex. Your initial capex need not go up. These are mindsets that we need to come up with. And what has helped us is basically involving more in the process. When you're investing in a technology, R&D and developing a technology is one aspect, and making it viable is another one. When you start investing in making it viable, that is where the full circle of success model comes in. Because see, using a smartphone became viable. It became a success story because today even the sabji wala has it. What made it viable? Because we involved technology in the process and made it cost effective. So once you come up with cost effective solutions incorporated in the design stage itself, look at the latest technology available to you and it's trusted because there is a certification program involved. Don't hesitate. We have that available. Incorporate, just get aware about the aspects, use the technology in the initial aspects itself and make the entire project viable for everybody.
Mr. Ujjwal, with this safety and hygiene being a new normal, do you think the standardized integration of MEP design should be a mandate for maintaining an IOQ?
See, I'll share a small story. When the pandemic happened, everybody was seeking for newer ways of newer products. So there are a product that we developed called sanitizing tunnel. What a tunnel was, it's a basic tunnel where the sanitizer has been sprayed by a very fine nozzles, and when people pass through it, we hope that all the COVID viruses get dies along with it. So we completed the whole sanitizer. We were ready to sell it in the market. Then there was a government announcement that has been made that certain sanitizer has been banned from being used, which is a very good thing. Although for our it was a bad thing. It causes losses, but on the India level, it was a very good decision made by government to standardize what has to be used, what not has to be used. Otherwise, everybody like in the market, everybody is now purchasing sanitizer for the hands. So nobody knows how much sanitizing percentage, how much alcohol percentage. Somebody, yesterday I bought a sanitizer. It has a propanol in it. So so there has to be some standardization to it. And uh, one more story that I want to share, that my friend Tushal Kalra, he works in a company called Camphil, and they do the indoor air qualities and everything. So one of the client wanted that he has to, the indoor air quality should be below 10 ppm or something, that the readings that they want. He he made the client understand that you don't need that much amount of cleanliness inside. You can live with a much higher kind of impurity in the air. The human body is sustainable. So there has to be certain kind of standardization on this, that what is good and what is overdoing.
Is it now increasing the cost of HVAC functions, especially when you look at working in this COVID time with sanitizers or PPE kits or even whatever the social distancing norm you need to maintain at the workplace?
See, there are two aspects in that. One is sanitization aspect. Now, which the market is flooded with sanitizers, and a lot of other such gadgets. Mr. Ujjwal mentioned about the tunnel also. Apart from that, in HVAC now, people are looking for a lot of importance on how to better the IAQ, how to make the indoor air quality COVID free, and these all. We have been getting queries as builder from the market and MNC clients that what are you doing on HVAC to make the indoor air purification. These all queries are constantly coming when we deal with MNC clients. So one of the good feature I have come across is UVGI. We have also put it on a trial basis in few of our AHUs, that ultraviolet germicidal irradiation, which is also incidentally recommended by ASHRI for COVID control. So we are working on that, and probably I think this UVGI should be able to serve the purpose of making the IQ, because this UVGI is a very old technology. In hospitals for purification of that, when I was searching it on Google, I came to know that initially it started from TB hospital, where they used to get the purification of supply air. They used to route it through the ultraviolet rays from TB hospital. So obviously this should serve the purpose, and IAQ should be better, and by using UVGI. I have personally started using it on few of our AHUs as a dry run for my building. At least people will expect the social distancing norm to be followed. So your office occupancy has to be impacted. Then lift traffic analysis will be different. Earlier, a 20 passenger lift, now because of social distancing it will run at half the capacity. These things will definitely increase your cost capex, and bottom line will get impacted, no doubt about that. But once you have that confidence inside the air conditioned spaces, if you can showcase that your indoor air quality parameters are so and so, ppm levels are this, carbon dioxide levels, and if these things are maintained, and I'm also exploring, I'm talking to these UV manufacturers, Alpha and all.
Where do we stand in terms of demand for safety and efficiency embedded MEP designs in India?
Sir, designing the system, while designing on the system, we always consider the efficiency of the system. While when we design the system, we see that what are the persons, or while designing, we also see what are the persons, occupancy, lighting load, equipment, and all this has been taken into considerations. Then what is the diversity factor in which it, how many occupancy would, if it is a sales office, it is not that it would be 100% occupancy, but would be that all the occupants would not be there. There would be some diversity factor in that. There would be some so that is why while designing the system we consider all these factors while designing the system. And regarding safety, so safety is normally we consider 10 to 20% safety, not up to that. Mr. Ujjwal said up to 50 to 60%. Around 10 to 20% safety is always advisable, not more than that. 10 to 20 50%, because we design, sometimes we design a system, there is a change in layout also. Sometimes we design the system according to one particular this, then the number of occupancy increases. Sometimes the number of layout changes if there is an equipment load inside it. Some while designing system there is no equipment load, then there is an addition of TV, refrigerator, then additional items come, then additional the loads also increases. That is why we have to consider 10 to 15% of the additional safety margin for it.
Dear panelists, is there any possibility for developing transparent solar panels in near future, which can be replaced the glass in building and which allows us to get electrical energy, which is sufficient for HVAC system, so that running cost almost drop by 50 to 60%.
My submission to him was that I would like to understand his system first of all, because you have to look at it in a complete understanding of what is the heat load that he's concerned about. Number one, let's understand what is his heat load and what is he using, the system that he has initially designed to cater to that heat load. We can contribute. I mean, I'm sure Ujjwal has his own contribution towards that. would have my own suggestions on that. And the simple solution is that let the indoor air quality and the energy running life cycle cost both be addressed simultaneously. Don't look at initial capex only, but look at both the aspects. Yes, we can address it. What you will leave for the solar panel to address and take up the HVAC load. Now, I'm not giving a solution on the solar panels, or I'm giving you a solution on how to reduce your loads. Or you can reduce your refrigeration load. And this is what Ujjwal can also contribute and I can also contribute. So we can give you a solution on how to address your air heat loads in a more energy efficient manner so that you can have part of it addressed through your solar panel.
When I was in MNIT, I was doing my research. There was a project going on BIPV, building integrated photovoltaics. So building integrated photovoltaics is basically what he wanted to know more about. It is like using photovoltaics for the windows and for the walls as well, not just the windows. So what we were trying to do is we were trying to see how much heat load can be catered of the direct solar radiation by using that heat load to convert them into energy and to use in the house. So what recent I'm aware of what is happening right now. They were semi-transparent modules, to be very specified of. They were not transparent, and I don't think it is. With right now, it's not possible to have a.
Thank you, panelists, for exchanging your valuable thoughts on today's topic of the future of India's MEP. We hope that you enjoyed our session thoroughly. Before wrapping up today's session, we would like to thank our distinguished panelists, Mr. Anirudh Bapat, Mr. Ravi Saran, Mr. Ujjwal Singh, and Mr. Suhas Randive. I would also like to thank our editor, Mr. Prasad Nair, for taking this initiative. So with this, we would like to announce the closing of our today's session. I request you to stay tuned for more such sessions. Until then, thank you and goodbye.